In this video, we are going to rationalize the denominator. So in these problems, what we will have is an irrational number in our denominator. We get an irrational number, or one of the ways in which we can get an irrational number is by taking the square root of a value that is not a perfect square. So for example, the square root of 25 is actually 5, so that is not an irrational number. However, the square root of, say, 10 or 5 or 7 will be an irrational number because none of those numbers are perfect squares. So when you have a number, let's say 6, that the square root of 6, which is irrational, and you want to make it rational, the only way to do that is to cancel out the square root. And the only way to do that is with the inverse operation, which is squared. So then this will produce a value of 6. However, another way to look at that is to say, well, instead of squaring it, you can multiply it by itself, which is really what squaring means. So instead of saying the square root of 6 squared, you can say the square root of 6 times the square root of 6. And that's basically the process that we will be using for these first two problems. So for problem number 1, I have a square root of 5 in my denominator. So I must multiply this by a square root of 5. However, since I don't want to change the fraction, I want to keep the equivalent fraction, I must also do that same operation to the numerator. So I'm going to multiply by the square root of 5 to my numerator. Now in my denominator, this becomes square root of 5 squared, which is 5. In my numerator, I have 4 times the square root of 5. We cannot actually multiply these, so that is what it is. In other words, we cannot change that at all or simplify that in any way. So this stays as 4 times the square root of 5, and that's my final answer. Don't try to cancel out these 5s because they're not the same value. The only way you can cancel out something in your numerator and denominator are if they are exactly the same value. Let's go to problem number 2, which is a similar problem. Notice how I have a coefficient of 5 in front of that square root of 7. I will actually not do anything with that, meaning that when I multiply this, I'm not going to multiply it by 5. I will multiply it by the square root of 7 only, and square root of 7 in my numerator. Once again, my numerator becomes 6 times square root of 7, so nothing really changes with that. In my denominator, I'm going to actually rewrite this in a slightly different way, just to show you that you have options. So we could also write this as 5 times the square root of 49. You can multiply roots by other roots as long as they are the same root. In other words, this little number right here is your index. With the square root, we never really write that number, but it exists, and it is 2. So as long as the index is the same, you can actually multiply these roots. So what I have now is 6 times the square root of 7 over 5 times the square root of 49. Now, I'm going to simplify this to be 6 times the square root of 7 over 5 times 7, which then gives me 6 times the square root of 7 over 35. For 3 and 4, you notice our denominator is a slightly different expression. Notice it has two terms. We have a square root term and either another square root term or possibly a rational term. So what we have to do is a slightly different process. In this case, what I'm going to do is multiply by something else, a binomial, meaning two terms, to get rid of any irrational values. So just a quick note, this is kind of the reason why we are doing this. If you have, say, a plus b as one of your binomials, and you want to get something to square a and b, what you will do then is essentially multiply it by a minus b. So when you multiply this, what you will get is a squared plus ab minus ab, and then minus b squared. So notice what happens with the middle two terms. The middle two terms are opposites and they do cancel out. So now you have a squared minus b squared, and essentially you square both of those two parts, which is exactly what we want to do. Whichever one you don't have, so for example with number 3, I've got the a plus b because it's square root of 2 plus 1. So I will multiply by a minus b. A minus b for number 3 would essentially be the square root of 2 minus 1. So in other words, the term is almost the exact same, except the second part is always opposite, only the second part. We call this the conjugate, by the way. So I have to multiply the numerator by the same thing. When I multiply the numerator, I get 3 times the square root of 2 minus 3 over, and now I'm going to multiply the denominator. Now you can choose to FOIL it out, and I'll do that for the first one if you'd like. What I get then is the square root of 2 squared minus the square root of 2 plus the square root of 2 and then minus 1. So very similar to what we see up here with the a's and the b's. And then from there, I can go ahead and simplify my denominator because notice the square root of 2's do cancel out. And so what I have is 3 times the square root of 2 minus 3 over 2 minus 1, which in turn gives me 3 times the square root of 2 minus 3 over 1, or just simply 3 times the square root of 2 minus 3. With the second problem, I'm going to multiply by, again, I'm looking at the first term being the same, and then the second term changing to its opposite. So now we have plus 3 times the square root of 2, and I will do the same to my numerator. So square root of 3 plus 3 times the square root of 2. Now I'm going to multiply and distribute the numerator. Now remember what I said with the previous problems. Notice what I said, that if you have the same root with the same index, which this is the same, they both have an index of 2, I can actually multiply what's called the radicand, the number under the root. So this will be square root of 6 plus 3 times the square root of 4. In my denominator, I'm going to go ahead and instead of foiling it out, I'm going to use my property up here or my pattern up here and recognize that that is what I should get. So I'll have the square root of 3 squared minus 9, because 3 squared is 9, times the square root of 2 squared. And so what I get here will be the square root of 6 plus 3 times 2 over 3 minus 9 times 2. From here I can go ahead and rewrite and simplify. So what I have, and I'm going to write the irrational part in my numerator second just because I actually tend to prefer that. However, it's not really necessary. So I'm going to put 6 plus the square root of 6 over, and then I have 3 minus 9 times 2, which is 3 minus 18, which is negative 15. All right, so another way to write that, by the way, which you can, again, this is all dependent on what the either instructor or the software that you're working with wants, but you can actually take that negative and pull it out in front if you'd like to, so it can be negative, and then 6 plus square root of 6 over 15.
Sassy McSass.